Hello and welcome to Transformer Embedded Synthetic Source Code Multi-Class Classification, or better known as AI-generated code detection. So the problem we're having right now is tools like ChatGPT are used by a lot of people to increase their efficiency, but the problem is a lot of people are also using them in academically dishonest ways. This can lead to a lot of people getting jobs and not even being able to tell you what a class is or a method is. So just reduce student proficiency. And so it's very important for professors to be able to catch on and identify these AI plagiarized works. So what is our proposed solution to do this? Well, we have a really powerful real-time automated deep learning model that can differentiate not just if the work is AI generated, but also which type of AI generated it. We did this by comparing 3 different pre-trained models and compiling their performances from publicly available data set. And the resulting model that performed the best can be deployed and used by teachers to determine the percentage of and put an end to AI plagiarism. So what exactly does it do? Well, it's capable of taking different languages, programming snippets, run them through the model, and be able to classify them as either human, chatbot, IDE extension, or Hugging Face model. So if we take a closer look at some of these snippets, just to give you a better understanding of what the model is looking at, it's for chatbot, you'd see these different code snippets, and then it's able to classify it. You'll notice that each one has its own different style and stuff, and we'll discuss that a little bit more in the next slides. How does it do this? Well, we use pre-trained end-to-end feature learning, so a different type of model that's already trained on either classification or summarization or whatever it is, and it tokenizes the new code snippets that you saw in the last slide, puts it through an encoder-decoder architecture model, uses self-attention to focus on the specific parts that are important, and then prints out a hidden output, which is then classified using some sort of multi-class classifier. In our case, we're using a random forest. So some of the features that we look for is stuff like comments, style, indentation, just a lot of different things that humans would do that an LLM probably wouldn't do. One example of this is spaces after comments. Humans tend to not put spaces after comments, and then LLMs do. And the specific models each have their advantages and disadvantages and their different ways of doing things. Just to name a few, GraphCodeBERT focuses on graphs to identify the different semantics. CodeBERT uses language modeling. And PLBART uses token masking and is well known for code summarization, all of which plays a part in these results where PLBART outperformed all the other models, and overall the PLBART just outperformed all of them, as you can see, in accuracy, recall, precision, and harmony. But some of the challenges we faced were dataset imbalanced, source code tokenization, and safely extracting the features. You just have to consider a lot more when you're processing source code rather than regular text, because regular text you can remove certain tokens out, but in code you need to consider everything. So that's it. Thank you so much for watching. Have a good day.